This is lesson 4.5. We are going back and forth between equivalent forms of a quadratic function equation today. Just a quick review of the previous lesson, lesson 4.4. I'm just going to write this on the side here. 4.4. We learned about standard form of a quadratic equation. If you need to go back and watch that lesson, please feel free to do so, because you do need to understand standard form in order to do this lesson. So standard form looks like this, and the advantage of standard form is that we can see the vertex. So just straight by looking at the equation. So it's the coordinates p, q. The p coordinate is the x coordinate, and then the y is the q in the equation. So that's the advantage of standard form. Sometimes people call that the vertex form just because you can see the vertex. Now, we also have a different form of a quadratic function, which is general form. And I'll show you that here. Y equals ax squared plus bx plus c. It's like the expanded version of the standard form. And so from this format, the advantage of this is then you can find the intercepts a lot easier. Intercepts. And we'll get more into detail into that in the next lesson, but you'll be able to find the y-intercept, which is just the c value, and then the x-intercepts by solving the quadratic equation for 0. So that's the advantage of the general form. So it's useful to go back and forth because you can get different information from either form. They are equivalent. If you draw the graph of the two different forms, that'll give you the same graph, but you just get different information from looking at the equation. So we can go back and forth, and I just want to mention the different strategies for going back and forth. So it's a lot easier to go in this direction, to go from standard to general. We're just going to expand to get there. So that's a lot easier. To go the other way, we're going to complete the square. So we have to remember that skill back from the previous chapter, the previous unit we did. Square. So we'll be doing that again today. So we'll start by expanding and showing you that first direction there because it is a little bit more straightforward, and then we'll complete the square to go in the other direction. Okay, so that's what today's lesson is all about, just going back and forth between those two types. All right, let's start by expanding. Here are some standard form equations listed here, and then some general form equations listed here. I'm just going to choose one of these. I'm just going to do this one here, the first one, and just show you how you would transform that into general form. So let's take this equation, y equals negative x minus 2 all squared plus 7. You would expand this. I like to write it out. The power of 2 means we are multiplying x minus 2 twice. So we are going to FOIL. Now, I like to keep that negative sign on the outside because it is going to apply to every term that I expand out when I'm doing my foiling. So it's going to be x squared minus 4x plus 4. And now this negative sign does apply to every single term in that expansion. So I get y equals negative x squared plus 4x minus 4, and then there's a plus 7 there. And I can combine those like terms on the end. So finally I get negative x squared plus 4x plus 3. Now this is the general form. I'm just going to box this in, and this is the standard form. So they are equivalent forms of each other, and if you graphed them, they would give you the same graph. I'm going to show you that in a second. I'm just going to label them here. This is standard. This is general. So let's go ahead and graph them. I'm going to pull up a Desmos screen here. So one of those equations was y equals negative x minus 2 squared plus 7. And then the other one was y equals negative x squared plus 4x plus 3. Yeah, and you can see those graphs lie, or actually I'll zoom out here so you can see it a little bit better. There we go. So you can see if I toggle those on and off, they are this exact same graph. So this is one quick way you can check yourself. If you have Desmos in front of you while you're doing your practice, you can just plug both equations in and make sure the graphs are lying right on top of each other, because it should be the same function. It's just that it's a different format. Okay, so now that we've done that warm up, let's go ahead and do another example, but this time we're going to go in the other direction. So we're going to start, so we went this way in this example. We are going to now go in this direction. Okay. We're going to skip ahead here to example 1. Example 1 says, determine the coordinates of the vertex of the parabola with the equation y equals 3x squared minus 12x plus 7. So I'm just going to write that a little bit bigger. Now notice the question does not say put this into standard form, but it does say find the coordinates of the vertex. So to find the coordinates of the vertex, we've got to get it into standard form, because from standard form we can directly read off those coordinates. Okay, so first step we're always going to do is factor out the a from the first two terms. You need to have a coefficient of 1 in front of the x squared term in order to complete the square properly. So the a value I'm talking about here is the 3. So if that is not 1, we need to factor that out. And we're just going to factor that out of the first two terms, because the constant term we're going to leave to the side for now. So let's see what that looks like. So I'm going to divide 3 out of the first two terms. So it becomes 3, and then in brackets, x squared minus 4x. And then we're going to leave a little bit of space, and then we're going to put plus 7. So I've left the 7 on the outside. Now we're going to figure out what we need to add in here in order to complete the square. So this is step 2, complete the square. And if you remember back to last unit, we had a little formula for that. So we took this b value, the coefficient in front of the x, so in this case it's negative 4. We divide it by 2 and we square that number. And that gives us the number that's going to give us a perfect square trinomial. So in this case, that is 4. So what I'm going to do here is add 4 into this bracket. Now I can't just randomly add 4 to an equation. It totally changes it. So I also have to do the opposite thing. So it's like I added 0 in a sense. So I subtract 4 as well. Okay, so now I'm just going to highlight here. This part is a perfect square trinomial, the part I'm highlighting in green. What I'm going to do now is remove that minus 4 outside the bracket, so then I can factor that perfect square trinomial. So next step here is we are going to remove that minus 4 from the bracket. And when I do that, I have to make sure I multiply it by 3, because this 3, remember, applies to every single term in the bracket, even that negative 4. So if I take it outside, I have to multiply it by 3. So it becomes negative 3 times 4 on the outside. Okay, and that 3 again came from that 3 that was on the outside of the bracket. Okay, now I'm going to factor this perfect square trinomial, because it is a perfect square. So this is step 3, factor the trinomial. And so in this case, the factors are x minus 2 and x minus 2. The two numbers that multiply to make positive 4 and add to negative 4 are both negative 2. So if you do this right, the two factors should be identical. We're doing that on purpose because we want a perfect square. So I can just simply write x minus 2 squared since the factors are identical. Now I can also combine these terms on the outside to make a subtraction, minus 5 there. Okay, and I'm done. I'm in standard form. Now the final answer to the question is, what are the coordinates of the vertex? Are, so we can just read it directly from the equation. It's going to be 2 and negative 5. Remember that you do have to change the sign of the x coordinate. It's not negative 2, it's just positive 2 there. So the x coordinate of the vertex is 2 and the y-coordinate is -5. Okay, we're going to do this 2 more times. We have 2 more examples with slightly different conditions that we're starting out with, but those same 3 steps are going to happen every time. So we're first going to factor out the a. You don't have to do that if there's a 1 as the a coefficient, but you do if it's not a 1. Then we're going to complete the square, and then we're going to factor the trinomial. Okay, so 2 more examples. This example here, negative 2x squared plus 5x minus 3. So first thing we're going to do is factor out the a. I'm not going to write the steps this time. I'm just going to do them. So I'm going to get this x squared. Now, if it doesn't divide nicely, that's okay. Just write 5 over 2. And again, remember, we'd leave the -3 on the outside there. Now, the number we're going to add, I'm just going to write this on the side to make the perfect square, is we divide that b value by 2 and we square it. If it's a fraction, think of dividing by 2 as multiplying by 1/2, and we're going to square it. So this is -5 over 4 all squared, which is 25 over 16. That's what we're going to add to make this perfect square trinomial. And you can't just randomly add 25 over 16. We also have to subtract it, because then it's essentially like we've just added 0. Okay, so now we have our perfect square trinomial that I'm highlighting in green there. I'm going to factor that in a second, but first I have to take out that -25 over 16, because that's kind of in my way. So I'm going to just rewrite this, minus 5 over 2x plus 25 over 16. That's my perfect square. And I'm going to pull out that 25 over 16, but I have to remember that this -2 does need to be multiplied to it. So that becomes positive 25 over 8 minus 3. So just on the side here, I'm going to show you -2 times -25 over 16 does equal 50 over 16, which reduces to 25 over 8. That's how I got 25 over 8 there. Okay, now finally, I'm going to factor what I'm highlighting in green there. So I think of 2 numbers that multiply to make 25 over 16, and those would be 5 over 4 and 5 over 4. And it needs to be negative, since these numbers need to add to -5 over 2. So there's my factors. They're both identical. And I'm going to add those constant terms on the outside. So it's going to be 1 over 8. Okay, so there, I'm done. I've done the 3 steps, and now I'm going to write the question was determine the axis of symmetry. So the axis of symmetry occurs at the x-coordinate of the vertex. So the axis of symmetry is going to be at x equals 5 over 4. And that's my final answer there. If I were to sketch this function, I know a lot about it already just by doing this. So I know that the x-coordinate is at 5 over 4. The y-coordinate is at 1 over 8. So maybe somewhere like here. And I know it's opening down. So I know this graph is going to look something like this, right? With my axis of symmetry at x equals 5 over 4. Okay, let's go on to the final example. And this last example will have an a value that is a fraction. Okay, so scroll ahead to example 3. And it's going to be those same 3 steps all over again, just with a different a value. Okay, so this time the a value is a fraction. I'm going to factor that out. So remember that dividing by 1 over 5 is equivalent to multiplying by 5. Okay, so when you divide out 1/5 from the first 2 terms, it's essentially like you're multiplying by 5. So it looks like this. So the 1/5 comes out, and you get x squared plus 10x. And remember, we're going to leave that constant term hanging out by itself there, then -1. Okay, you can double check that this works, right? If you multiply this 1/5 back in, it does equal the original. So 1/5 times 10 is 2, so it makes sense. Okay, now let's figure out what we need to add to make a perfect square trinomial. We're going to take 10 divided by 2 and we're going to square it. That is 25. So I'm going to add 25 and subtract 25. Okay, and finally we're going to factor this perfect square trinomial that I'm highlighting in green there. But before we do that, we need to pull out that negative 25. And I have to remember that this 1/5 needs to be multiplied with it in order to pull it out of the bracket. So let's write down what we have now. So we have my perfect square, and when I pull that 25 out, it's going to equal -5. Okay, because 25 times a fifth is 5. Finally, factor the perfect square that I'm highlighting there. It's going to be x plus 5 all squared. And then on the outside, combining those numbers is -6. Okay, so I'm finally finished, and let's see what the question was. It says determine the y-coordinate of the vertex. So my vertex is at -5, -6. I just get those numbers from here and here. Remember, you do have to change the sign of the x-coordinate. And so the y-coordinate is simply -6, because this is the x and this is the y. And we can see that matches the answer down here. Okay, so I've shown you 3 examples of how you go from general form into standard form with 3 different types of a values, but you're using the same 3 steps every time. Factor out that a, move the number to the outside of the bracket, factor that perfect square, and then you're done. All right, that's the end of the lesson.